Okay, so today we are going to quickly discuss significant figures. This is going to be our fourth lecture in our introductory unit of what is chemistry, also known as Unit 0. Our overall objective for this lecture is to determine the correct number of significant figures when recording scientific data. And saying that, let's jump into our lecture. To understand the importance of significant figures, we must be able to discuss the difference between precision and accuracy. Precision is the closeness of multiple points in reference to each other. Think of a basketball player who never makes a shot. This player can still be a very precise player despite not making a shot. This player can hit the same spot on the backboard every time, or relatively close to the same spot, whether that's the top left corner, top right corner, or just hits the rim every time. Whatever it is, as long as he is hitting the area close to each other, that is going to be considered a precise. So all the measurements, all the data points are close to one another. That's precision. Accuracy, on the other hand, is the closeness of points to a known standard. For a basketball player to be considered accurate, they must consistently hit the standard of making a basket. So for accuracy to be a thing, we have a known standard or something that we are aiming for. And we are trying to get close or hit that mark every time. So for experimental data to be considered valid, it must be precise and accurate. In other words, it must hit our desired mark, and it must be repeatable, and you must be able to be close to that mark. In order to make data both accurate and precise, scientists use the rule of significant figures. Significant figures is a way to count numbers to reliably compare data. There are 3 rules for counting significant figures. First rule, all non-zero digits are always considered significant. In other words, a number that's not 0, you count as significant. Rule number 2, any 0 that is sandwiched between 2 non-zeros is considered significant. So for example, the number 101. You have 2 non-zero numbers, the 1 at the beginning and the 1 at the end, and 1 0 between them, giving you a total of 3 significant figures. The third and final rule of counting significant numbers or significant figures is that we only count trailing zeros if there is a decimal point. For example, the number 100 only has 1 significant figure because the 2 trailing zeros are not counted due to the fact that it does not have a decimal point. If I have the number 1.00, now I have a decimal place and I can count my trailing zeros, giving me a total of 3 significant figures. Let's end this video by working through a few practice problems to determine the number of significant figures in each of the following examples. So I'm going to read them out first. 0.003, 114.0, 0.00310, and 5.0032. If you want to try these on your own first, go ahead and pause the video now and attempt to figure out how many significant figures are in each of these examples. Okay, so let's start with 0.003. When counting significant figures, or sig figs for short, we start with our non-zeros. So we have 1 digit that is a non-zero, or one that is not a 0. That would be our 3. Next, we look, do we have any sandwich zeros or trailing zeros? Though we do see a decimal place, there are no zeros after the last non-zero number. So we do not have to count those leading zeros. Now we add all the digits we got from our rules together and we get a total of 1 significant figure. Next one, 114.0. Okay, we see that we have 3 non-zero numbers, the 2 1s at the beginning and the 4. This gives us a total of 3 non-zero numbers. Now, we do not see any sandwich zeros, so we do not have to count them. Finally, we do see a decimal place and 1 0 after the last non-zero digit, so we can count that as 1 significant figure. All we have to do is add all of our significant figures up, so our 3 non-zeros and our 1 trailing 0, and we get 4 significant figures in this number. Next, we have 0.00310. Looking at this, we have 2 non-zero numbers, the 3 and the 1. And then we also have 1 trailing 0 after the last non-zero and we have a decimal point. We do not see any sandwich zeros, and our leading zeros, or our zeros in front of our first non-zero number, do not count as significant. So we have 2 non-zeros, 1 trailing zero, giving us a total of 3 significant numbers, or 3 significant figures. Our last example is 5.0032. In this number, we have 3 non-zero digits and 2 zeros sandwiched between 2 non-zeros, giving us a total of 5 significant figures in this number. As always, I hope this helped you out and gave you a better understanding of the topic of significant figures. If you need to, review the playlist. This is the last video in Unit 0, so you can go ahead and start Unit 1 if you want. And saying all that, keep up your good work in the class, and I'll see you next time.